Bismillahirrahmanirrahim. This is the half wave rectifier circuit. Actually, rectification is a process of converting AC waveform into DC waveform. This is an AC waveform and we want to convert it in DC like this. This is DC voltage, a straight line. Now let's simulate this circuit and see rectification process. There are two waveforms. The green waveform is the input waveform and it is a complete sine wave, while blue waveform is the output waveform or rectified waveform. There is no negative side of this waveform. The blue waveform is half waveform. This is because during positive half cycle of the sine wave, diode D1 is conducting, while during negative half cycle diode is non-conducting. Also see, there is a voltage difference of 0.7 volt between two waveform, that is between input waveform and output waveform. You can check the values as well. 9.27 is the magnitude of output waveform, while 9.9 is the magnitude of input waveform. This is because of the diode drop. Now we want to get a straight line DC voltage, but we get pulses of DC voltage, pulses like this. These pulses are of no use in practical purposes, but the question is how to remove these pulses. So we need to increase a capacitor to remove these pulses. Like we have got these pulses of DC voltage and its peak value is 9.27 volt. Now add a capacitor here. Its value is changed to 500 microfarad. I will discuss how to choose this value. In another video, I will show you how to choose this smoothing capacitor value. Now, the blue waveform is the output waveform and it has only ripples, and these ripples are because of charging and discharging of the capacitor. Actually, these ripples are because of a capacitor charging and discharging. And if we change the schematic or improve the circuit from single diode to two diodes, we get rid of these ripples as well. We need to get a straight line DC voltage, but first we get pulses and then we get ripple voltage. We get like this. We can get the result approximately same, but it is better to get rid of these ripples as well. We have applied sine wave with peak value of 10 volts. Now the question is, what is the value of this DC voltage? So this is the formula of the DC voltage obtained from this rectification process. This is 1 upon T. Actually this is simply integration, and this is integrated over 0 to pi 0 because of half wave, and its period is 2 pi. This is sine wave. And Vt is equal to Vm or VP. VM or VP is same. VP is peak voltage and VM is maximum voltage. VM sin theta, and we will integrate this. This is 10 volt, or peak voltage or maximum voltage is 10 volt. So substitute 10 here, and period is 2 pi because it repeats after 2 pi or 360 degree angle. After integrating, we get 31.8% of the voltage, peak voltage, 0.318 VP or 31.8% VP. Similarly, for RMS calculation, this is the formula, and we get 0.707 VP after integration, or VRMS is 70% of the peak voltage. Thanks for watching. Goodbye for now.